Hello everyone and welcome to today's session on inheritance in Python. Do you know friends, Python is a language that needs no introduction. This programming language demand and popularity have skyrocketed in the recent years. Python is ranked first among multiple programming languages in a variety of reputable indices. Now before we discuss our today's agenda, do not forget to hit the subscribe button and click the bell icon. So first, we are going to study about what is inheritance. Moving ahead, we are going to discuss about why do we use inheritance. Then we are going to learn about single inheritance. Moving ahead, we are going to discuss about multiple inheritance. Then we are going to learn about multi-level inheritance. Moving ahead, we are going to learn about hierarchical inheritance. And at the end, we are going to have a hands-on on inheritance. So let's start with what is inheritance. Inheritance allows us to create a class that inherits all of another class methods and attributes. The class being inherited from is known as parent class and sometimes also known as the base class. A child class which also inherits from another class also known as the derived class. So if I define inheritance, inheritance refers to a class capacity to derive features and traits from another class, one of the most significant aspects of object-oriented programming language. Inheritance is a feature or a method that basically allows a new class to be built from the existing one. The newly generated class, which I already told you, is basically called as the derived class or the child class. Now, when we state that a derived class inherits from the base class, we imply that it inherits the base class properties without modifying them and may add new features of its own. But the question is, why do we use inheritance? The major function of inheritance, in my opinion, is to stimulate the relationship between the class. Inheritance, when utilized effectively, is not exactly about reusing the existing code, it's more about being utilized by the existing code. That is, if you have an existing code that works with the current base class, when you derive a new class from that existing base class, that other code will also now work with your derived class as well. When you want the object to utilize all of the functionality of the base class until expressly modified, inheritance is the simplest, the least verbose and the most straightforward method to describe it. Now let's discuss the types of inheritance. The number of attributes from a single parent class, allowing for the code reuse and the addition of new features to the existing code. The next one is the multiple inheritance. This sort of inheritance occurs when a class can be derived from more than one base class. All of the features of the base classes are inherited into the derived class in multiple inheritance. The next type of inheritance is the multi-level inheritance. In multi-level inheritance, the characteristics from both the base and the derived classes are inherited deeper into the new derived class. This is kind of comparable to you have a father and a grandfather connection. The next one we have is the hierarchical inheritance. This sort of inheritance occurs when more than one derived class is built from a single base class. We have a parent base class and two child classes in this program. Now let's try the hands-on on inheritance in Python, where I will explain you how to create inheritance in Python. So the IDE which we'll be using is Google Colab and I will show you how to use it. So first go on your Google and then type Google Colab. Now click the first link which says welcome to the Collaboratory. Now your Google Collaboratory has opened. Now you can type here new notebook and give a name of your notebook. You can see here that our notebook has opened and here you can give the name of your notebook. So as you can see here, I have given the name of the notebook as inheritance.ipnb. Now we will create a parent class. Now as you can see, I have created our parent class as car. Now the next thing which we are gonna do is declare our init function. So now as you can see, I have declared the init function in which I have added the parameters such as self, name and year, and I have declared all of them all over here, in which I have written self.cname equals to name. In short form, this denotes basically the car name, and self.yname equals to the year name. Now I am going to define a function called define print name, in which I'm going to print these two parameters which I have included in the init function. Now you can see here I have declared another function called printName, which I have written def printName, and I've added the parameter self, which denotes I'm going to add the name and the year. So inside print I am adding self.cname and self.yname. Self.cname denotes the car name and self.yname denotes the year. Now let's create the car class object and execute the printName method. So now as you can see, I have created our class object and declared it as y, in which I have used car, and inside the bracket I have written Ford and the year 1975, and then I am printing y.printName. So you can see our output will be Ford and 1975. So now let's run our code and see what we have written in our parent class. So I'm gonna click on this button, and you can see it's directly coming Ford and 1975 because our object is taking two parameters, which is self.cname, which is a name, and this as a year. Now, in order to create a child class which extracts the functionality from the parent class, you can send the parent class as a parameter when creating the child class. For example, in this case, I have added class Ford and have passed our parent class as car. Now, you can use the pass keyword when you don't want to add another properties or method to the class. So in this, I have not added any, so I have passed pass. Now I have used the same object X and I have used our class as Ford and I have passed these two parameters such as name and the year. Now let's print and call the method of our parent class. So see, let's what happens. So you can see our object has printed these things which we have added in our parameters as Mustang and 1975. Now in this program, I have added the init function. When the init function is added, the child class no longer inherits from the parent's init function. To maintain the inheritance of the parent's init method, we can add the following, in which I have added the car.init and I have called the self, name and the year parameters. Now let me run it and show you how we can include the init function. So you can see it's printed Mustang 1975. So whenever using the init function of the parent's class, you have to call the class name, basically of the parent class. Here it is car. Now as you can see, we will be using the super function. So I have created our parent class all over here as earlier. Now I am creating our child class Ford and I have defined the init function. Now as we have told in the earlier program, you can see that we have used the car name, which is our parent class name. So instead of the same, you can use the super function all over here. So what happens basically, Python also includes this super function that will make the child class inherit all of the parent class method and properties. So we are basically inheriting name and year. So our parent class says called car has the properties of name and year. And same, our child class Ford is inheriting the name and the year. Now you can see I have added one more functionality all over here, that's called price. So you can add on different properties. So similarly I have added self.price and I will try to print the same. So as you can see, I have created our child class Ford, in which I have added the parameters same as Mustang and 1975. Now I'm trying to print self.price. So you can say print x.price. So let's see what's our output. So you can see here the dollars have been printed for our car price. Now one thing can be noted all over here is that you don't have to mention the parent's element's name when using the super function. It will automatically inherit its parent methods and attributes. Now the further extension to our program will be adding methods. So we are going to add a method called Congo. Basically I mean congratulations. And I'm going to add some definite parameters all over here such as price. In the previous program, I have told you why are we using the super function, because we are inheriting the properties of our parent class. Then I have declared self.price equals to price. Now here I have declared our new method inside our child class, which is Congo. So def Congo, and I have added the parameter self, which is going to add the properties such as name, year and price. And this function I'm basically trying to print congrats for your purchase of self y.name, self c.name of price self.price. Now I have declared our object here of our child class, which has the properties such as Mustang, 1975 and the price. Now let's try to print x.congo. So you can see all over here, it's written congrats for your purchase of 1975 Mustang of price $10 million. I hope so you would have got idea about how we can declare inheritance in Python by creating the parent class and then the child class, and we have also added the super function in order to inherit the functionality of our parent class. Then we tried to add some methods so that we could add some new attributes or property to our object. So this was our earlier program. Now the next program we are going to try out is types of inheritance. Now let's try to create a program for the single inheritance. So let me remind you what is single inheritance. In this, it is allowed that a derived class to inherit attributes from a single parent class. It should be always noted that the derived class is always inheriting the attribute. So basically, in the single inheritance, our child class is actually deriving its attributes from a single parent class. So that's why it's called as single inheritance. Now, let me show you what I have done. So I've created our class called car and I've defined a method called hello, in which I have declared as a parameter called self, and I'm printing in this def method called print I am Ford. Then I have created our derived class, which is Ford, and in which I have passed our parameter car, which has a parent class. You should always note that this child class should derive or inherit the properties from only the single parent class. So as you can see, I have declared our method called def and I have added the method say, and I have called the parameter self, which is already present in car, and I am saying print I am Mustang. Now, so I have declared our object as Ford and I have called object.hello object.say. You should note that I have called the object of the Ford, which is our child class, and child class is calling the method of the parent class and its own class. So let's run the code and see how our single inheritance works. So you can see first it's printing I am Ford, which is basically in the method of the parent class, and next it's printing I am Mustang. So Mustang basically is present in the Ford, which is in our child class. So as you can see all over here. I hope so single inheritance is clear to you. Now next move to the next one. Now let's create the multiple inheritance. In this inheritance, a class can be derived from more than one base class. So in this program, basically I have created our parent class as car, and in this I have declared a variable called cname. The next is I have defined a method called car, and you should be noting one thing, that the method is capital. Don't do the small letter, otherwise you are going to get an error. So basically def car, and I have added the parameter self, and I have called print self.cname. Okay, this is our parent number 1. The next parent 2 is class bike, and I have declared a variable called bname, and I have defined the method called bike, and in which I am basically printing self.bname. Now here I have declared our derived class, which is Suzuki, and I have passed our both of the parent class, which is car and bike. Now as you can see, I have declared a new method called vehicle. This is our basically the child class, and I have added the parameter called self, in which basically I am printing car self.cname and self.bname. So as you can see, both of these parameters are from two different parent classes. Now I have created the object of our child class, which is Suzuki, and I'm calling basically x.cname, which is equals to desire, and x.bname, which is equals to Hayabusa. Now I'm calling the method x.vehicle. Now let's see and print it, and let's see how our multiple inheritance works. So as you can see, it's printing car desire and bike Hayabusa. So this is one example of a multiple inheritance. The next program which we are going to discuss is the multi-level inheritance. In basically multi-level inheritance, the characteristics from both of the base and the derived class are inherited deeper into the new derived class. Let me show you how this is happening. So first we are creating our parent class as grandfather. So in which I have defined our init function, and in which the parameters are self and grandfather name. And I have also called self.grandfather name equals to the grandfather name. And next I have created an intermediate class, which is father. And next I have created father as our next child class, which is inheriting from the grandfather class. And I have defined the init function as self, father name and the grandfather name. And I have called self.father name equals to the father name. and also invoking the constructor of our grandfather class. So I've called the grandfather class .init self.grandfatherName as I've told you earlier. Now next I'm using the derived class in which I'm calling the son and which is deriving from father, and I'm also doing the def init function calling self son name, father name and the grandfather name, and I'm calling self.son name equals to the son name. Now I'm invoking the constructor basically not from the grandfather name, I'm basically invoking from the parent class which has been inherited, which is the father. So father.init self father name and grandfather name. Now in this I have declared a function called print name self, and which I am printing the grandfather name, the father name and the son name. Now I have created our object of our child class of the son, and I have added Neil, Arm and Strong as a parameter. The first thing which I am printing is s.grandfather name, and the next thing I am printing s.print name. Let's run the code and see what happens. So as you can see, my grandfather name is coming as Strong, father name is Arm and son name is Neil. So the overall becomes Neil Armstrong. I hope so this would have given you some advice about how to create the multi-level inheritance. Now let's discuss the final type of inheritance, that is hierarchical inheritance. In this inheritance, it occurs basically when more than one individual derived class is built from the single base. We will have a parent class and then two child or derived classes in this program. So let's see all over here. Here I have the class called parent and I have defined the function as self, and I'm calling print the function is in parent class. Now this is our first derived class 1, I'm calling as child 1, and which is directly inheriting from the parent. Define function 2 self print this is child 1. The next one is derived class 2, child class 2, and I'm also deriving directly from our parent class, which is basically parent, and I'm calling the function as define function 3 self, and this is printing basically this function is in child 2. Now I'm using the driver code all over here, creating the object of child 1, child 2, classes basically which is object 1 and object 2, and I'm calling the functions respectively. Now the first object 1 of child class 1 is calling function 1, and similarly it's calling function 2, and similarly the object of second derived class is calling the function 1 and the function 3. Basically you should note one thing, that function 2 and function 3 are two different functions of two different derived classes. Now let's run the code and see our output. So as you can see all over here, this function is in parent class, this function is in child 1, this function is in parent class and this function is in child 2. I hope so you would have got idea regarding what is hierarchical inheritance. That was all for today's session. Thank you very much for staying so long. I hope so you would have got idea regarding what is inheritance in Python.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.